Okay, so today's class we are looking at volume of pyramids and cones. So pyramids and cones, we've got them grouped together because they've got a similar formula. They have 1/3 the volume of a prism or cylinder with the same base and height. So the formula we use is 1/3 capital B times H. That capital B, it still stands for area of the base, and then H stands for the height of the figure. So let's take a look at our first example. So here we have a square pyramid, reason being the base here, it is a square. All right, so these four sides will be the same with a measurement of 4 hectometers. And then the height of this pyramid is 12 hectometers. So using our formula, the first thing we'll do now is substitute everything in that we know. The first thing I like to do though is write out the formula for the area of the base. So since it is a square, the area of a square is side squared and then multiplied by height. So I just kind of write that out before we start substituting in our values. So that will give me 1/3 4 squared and then the height at 12. And when we're putting this in your calculator, you can multiply. You can type in 1/3 times 4 squared times 12. Another way you can type it in is the 12 times the 4 squared and then divided by 3. So a couple ways there to type that into your calculator. I'd like you guys to try that, typing it into your calculator, whatever you feel comfortable doing. Your answer should be 64 hectometers cubed. Give that a try. All right, the next one here we have is a rectangular pyramid because we have base that is rectangular. It's 30 by 20. And then the height of our pyramid is 40. It's all in decameters. So let's start by writing out our area of our base formula. It's a rectangle, so that would be length times width and then times our height. All right, so now we can go ahead and substitute in all the values. So 30 times 24 times 40. All right, so again, it's all just being multiplied together. 1/3 times 30 times 24 times 40, and you should get 9,600 decameters cubed. Good. All right, so for this example, we're going to start with what is the base? The base is definitely a rectangle. The area of the base is going to be 15 times 12. So I'm just going to show that I'm doing 15 times 12, which is 180 decameters squared. The height of the pyramid is 20 decameters. The specific volume formula is, so we know its volume is 1/3 area of the base times height, and that would become 1/3. The area of the base is a rectangle, so length times width and then multiplied by height. All right, and then the volume is, I'll just do the volume down here. So it's 1/3 the length times the width times the height. All right, and we just have to multiply that all together. Don't forget the 1/3, and we get the volume as 1200 picometers cubed. So next we are looking at the triangular pyramid. So our base is a triangle. And then we have our height here is 18 meters, and we have our sides there of our triangle. So volume is equal to 1/3 area of the base, because it is a triangle. The area of a triangle is 0.5 AB. A is the altitude, B is the base, and then multiplied by the height. All right, now we can go ahead and substitute in our values. So 1/3 times 0.5 times the altitude, which is 5, times the base, which is 9, and then times the height, which is 18. All right, so don't forget that 0.5, don't forget that 1/3 when you're putting it into your calculator. I'll give you guys a moment to try that. So the volume for this, when we put it all into the calculator, you should end up with 135 meters cubed. So let's substitute everything in here. So 1/3 times 0.5 times the altitude, which is 3.6, times the base, which is 10, and multiplied by the height, which is 18. Okay, and that gives us our answer of 108 meters cubed. Next, we are looking at a regular polygonal pyramid. Formula is still the same. Area of the base, this is a regular polygon, 1, 2, 3, 4, 5, 6, six-sided. So it is a hexagon. So recall, area of a regular polygon is 0.5 ANS. So 0.5 ANS multiplied by H being the height. A is the apothem, so 2 meters. N is number of sides, six-sided, and S is side length, which is 1.5 meters. So let's substitute in all those values. So 0.5 times the apothem, which is 2, times the number of sides, which is 6, multiplied by side length, which is 1.5, multiplied by the height, which is 5. All right, put that into your calculator. You should end up with 15 meters cubed. Give that a try, make sure you get that answer. So volume of this then is 1/3 times 0.5 times the apothem, which is 4.8, times number of sides. This is 5-sided, 1, 2, 3, 4, 5. And the side length is 6.4. And the height is 15. All right, so we just have to put all of that into the calculator. It's all just multiplied, and we should end up with 384 meters cubed. Lastly, we are looking at a cone. Volume formula is still the same, 1/3 area of the base times height. We have a circle as the base. Anybody remember the formula for area of base, area of a circle? Okay, so 1/3 area of the base is pi r squared, and then multiplied by its height. All right, so we're just using 3.14 for pi. Radius is 5 squared, and then multiply the height is 15. All right, remember squared here, it's 5 times 5. Okay, so put that into your calculator, 392.5 hectometers cubed. Okay, so volume is 1/3 area of the base times height. Area of the base is pi r squared, and then it's multiplied by height. We use 3.14 for pi. Radius is 5. It's 5 squared multiplied by height, which is 8. Multiply all of that together, and we get 209. And then 0.3, we can just round it to 0.3. It is repeating. We'll just round it to 0.3 meters cubed. All right, lastly, I just had a quick video. It's just showing how a volume, specifically for the cone, how it is 1/3 of a cylinder. So I'm just going to pause here.